Hey, welcome back for some more root beer where we're going to be continuing on our look at the 2014 paper for the Cimc. That's the grade 9 and 10 paper. We've already blasted through part A. We're into the written portion, part B now. So let's take a look at question number 2. So in the diagram, triangle PQR is right angled at R. If PQ, so that's the hypotenuse, is 25 and RQ is 24, determine the perimeter and area of triangle PQR. Okay. So if you're good with Pythagorean triples, you might already know the other side length PR is 7. Okay? 7, 24, 25, this is a common Pythagorean triple. It comes up occasionally on contests, and so if you're deep into contests, you should know Pythagoras' theorem, and you should certainly know some of the basic ones like 5, 12, 13, 7, 24, 25. But let's take a look. If you just knew Pythagoras' theorem, how do we figure this out? Okay, so we would have triangle here. P, Q, R, we're right angled at R. You know, this is 24, this is 25. You know, A squared plus B squared equals C squared. For right triangles. So x squared plus 24 squared, 25 squared. In fact, we don't even need this x here. We can just say PR, the length PR. So PR squared is going to be 25 squared minus 24 squared. So that's 625 minus, I think it's 576, but I'll just double check on my calculator. That's what they're there for. Yep, 625 and 576. Yep. So when we subtract these two, we get it's equal to 49. And PR is equal to 7. Okay, let's just clean that equal sign up so it doesn't look like a not equal sign. So now our triangle that we're looking at is 25, 24, and 7. So area is 1/2 base times height. So the base is 24, height is 7. So that's 12 times 7. That's 84. Okay. So now we've already got the area, and we could put that in a little box so the people who are marking know to look here. It's 84. And the other thing we're asked for is perimeter. So to figure out the perimeter, we just need to add up each of the edge lengths. So that's 7 plus 24 plus 25, 56. We can put a little box around that. Oh, you may have a little statement at the end. The area PQR is 84. So a nice clean statement. We were able to use Pythagoras' theorem to figure out the remaining edge, which gave us both the height of the triangle and also the missing side length to figure out the perimeter. So that was A part. We have a B part, and I think that's it. Yeah, B part. So in the diagram, triangle ABC is right-angled at C, with AB equals C, AC equals little b, and BC equals little a. Okay. Also, triangle ABC has perimeter 144 and area 504. Determine all possible values of C. So we might be getting one or two different forms of C. Thinking ahead, with Pythagoras' theorem, we're squaring a lot of things, so I'm guessing it might come down to solving a quadratic. So there might be two different values of C. But let's take a closer look at the question. So what did we have? We had A, B, and C. And the side opposite that angle was the little letter, A, C, B. Okay, so things we can say right away, A squared plus B squared equals C squared. Does this help us? I don't know yet. But we can immediately say A squared plus B squared equals C squared, even if that does not help. So, perimeter is 144. But how do we calculate the perimeter in terms of these guys? A plus B plus C. The area was 504, and that's 1/2 base times height. Okay. So, I want to figure out possible values of C. I'm guessing I'm likely going to have to figure out the whole triangle. I'm going to have to figure out what A and B and C are. So I'll get possible triples, and I'll just need to check what the C value is. So I can immediately rearrange my perimeter equation and say, this is what C is. And I can plug that into my Pythagoras Theorem formula. Okay? So A squared plus B squared is equal to, now I need 144 squared. Minus 2 times 144a minus 2 times 144b plus a squared plus b squared plus, because it'll be minus a times minus b, so plus 2ab. Okay, so that's just by inspection. If you need to, if you're comfortable with that, you could use FOIL and FOIL it out. You could also look at this as 144 minus a plus b, so keep the a plus b together and then work it out. Either or, it's entirely up to you. So immediately this a squared and this a squared, they're going to cancel. This b squared, this b squared, they're going to cancel. Okay. We want to simplify this a little more. So what can we do? Well, I can get rid of this AB right here. So if 1/2 AB is equal to 504, that means 1008 is equal to AB. Right? Multiply through by 2. So we can substitute B is 108 divided by A. Then we get 0 is 144 squared. So what's that? Uh, 20,736 minus 288A minus 288 1008 over A. So I can definitely see I'm going to multiply through by A and get a quadratic. Plus 2 times 108. All right, when we plug this into this formula right here. This 1008 equals AB. We plug that in for AB, so we get 2 times 1008. All right, so if we multiply through by A, we get 0 is equal to 2,736A minus 288A squared minus, what's 288 times 1008? So some big numbers. I'm guessing there'll be a common factor. Plus 2,000, oh no, 2009, 16. And that'll also be A. Right, so I don't like minus something in front of my A. I prefer it to be positive. So we can rearrange. And we can actually take out a factor of 288. I'm going to sort of skip just a bunch of rearrangement steps. So we had 2016 plus 144 squared. If we take out a factor of 288 from there, we get 79. That's 79A. And then what was our other number? Our constant term, what was that? That was 290304. We can take out a factor of 288 there, and it's just 1008. Oh, geez. Was that plus or was that minus? So that minus became a plus. Those pluses became minuses. That minus will also become a plus. So plus. So if one of these two things has to be 0, because you can't multiply two non-zero things and get 0, one of these has to be 0. 288, definitely not 0. So we can say A squared minus 79A plus 1008 equals 0. So quadratic formula, A equals negative B plus or minus the square root of B squared minus 4AC. So 4A, so that's 1C. 1008 all over 2A. So that's just going to be 2 right now. All right, 79 plus or minus, so what's 79 squared? That's 6241 minus 4032 all over 2. So square root of 2209, I believe that's 47 squared. I think so. Once you get into the thousands, it's hard to keep track of all of them. But it ends in a 9, so it's got to be a square of something with a 7 or a 3. So we hit square root on our calculator. Yep, it was definitely 47. And when we work each of these out, we get A is either 63 if we take the positive root, or sorry, the positive way of doing things, and then if we used that minus sign, we'd get 16. And we know what B is. B is 1008 divided by A. So 1008 divided by 63 is 16. And 1008 divided by 16 is 63. So either way we get A is 16, B is 63, or A is 63, B is 16. So there's really only one triangle. It's just the fact that there's no way to tell A and B apart is why we keep getting these. So a couple different ways we could figure out C. We could use Pythagoras' theorem, or we could just use this perimeter equation. So 144 minus A minus B. So that's equal to 144 minus 63 minus 16. Or we can do it the other way, but both of these will come out to be, I'm pretty sure it's 65. Just remembering my Pythagorean triples. Yeah, 65. Alright. So, even though we could pick A and B differently, we're still going to get the same C value, which is 65. And really, that was the only one we could have. Okay. And this makes sense. We're given two pieces of information about the triangle, its perimeter and its area. And what it essentially amounted to sort of solving a quadratic. So two pieces of information should be enough to pin down a single solution for a triangle right there. And it did. There was only one possible value of C, and it was 65. So good geometry question. I mean, not really geometry based, just because we didn't get into all the angles and everything. But a good Pythagorean triples or a good Pythagoras' theorem type question. Had some nice algebraic manipulation in it. So that's question 2. We just have one more question to go. So please join me next time as we finish off the 2014 CIMC paper.